Okay, welcome back. We're talking about the difference between kilovolt amps and kilowatt hours. So one of the other measures, particularly when you're talking about, well, UPS is a good example, is a power usage effectiveness, a PUE. So basically what we're saying is if I have power going into something and 40% of the power isn't directly related to getting work done, in other words, 40% is lost, that would have a power effective PUE of 1.4. And believe it or not, 1.4 is not bad. In other words, it takes 14 units of energy to get 1 unit of energy out. I'm wasting 40%. Okay? So, that's actually not bad. When you come to air conditioning, those numbers are a heck of a lot of energy has to be put into those things to figure out how much cooling you're going to get, which is why these companies are coming up with these outlandish ways of cooling, by using ocean water and submerging these things, all sorts of other crazy stuff. So natural air conditioning, if you pick a location for a data center on the North Pole, you probably be, not that would be a good place for other reasons, but nevertheless, it would be pretty doggone easy to cool it. Okay. So cooling and the environment, one more time. So page 1096, they talk about the optimum servers. They ought to be running at between 68 and 77 degrees. Now recently they changed that. They said, okay, how about 64 to 80 degrees? And once again, a lot of smart people have sat down and figured out, okay, if I run at 80 degrees, here's my cooling cost and here's my repair cost. And if I run at 85 degrees, my cooling cost is going to go down, but my replacement cost is going to go up. And so if I run it at 90 degrees, well then my cooling cost is going to go up a heck of a lot and my replacement cost is going to go up. And they've done the math to figure out where the trough in this thing is. Where do I save the most amount of money? And it is not 80 degrees. It's a lot hotter than that. Okay. So, if you're trying to come up with an optimum solution where you're based upon money, it's okay to run these things hotter than the design criteria, knowing full well that the failure rate is going to increase. But if the cost to repair is cheaper than the electricity it takes to do the cooling, well, then you're coming out ahead. Okay. So, yes, higher failure rate would ensue. Great. Okay. So, in a typical data center, not talking about a super duper data center, they probably have one of these things of separating hot from cold areas. In other words, they'll have rows of 19-inch racks where they have cold air coming through the floor. Remember we talked about the only not practical. One of the recommended things you can do is have the cold air go through the floor, and then it daylights coming up, and then it would just run through the racks. The racks are back to back. You can't actually see it here, but the racks are back to back, so the cold air comes up between them and gets sucked through the rack and shot out through the top. So you have a cold aisle and a hot aisle and a cold aisle and a hot aisle. Okay, so this is a cool way. This is an interesting way of separating out to maximize, because you don't ever want to have like a rack over in the corner that's not getting as much cooling as the rack in the center of the room. That wouldn't work. There's another way of doing it. It's called in row. So inside a row, looking down upon something is I basically have cooling between some racks, and so the cooling provides cool air to the adjacent racks. That's kind of interesting. I haven't actually seen one of these in real life, but that kind of makes sense to me. Because again, you're trying to distribute the cooling capability as much as humanly practical. You don't ever want to have a rack sitting someplace that's not getting adequate cooling. Humidity. They really don't really like low humidity, and so they have a range. They say between 8 and 60. Nobody runs at 8. Okay, I'm just telling you, that's just dumb. I want to keep static electricity down, and so somewhere probably between 20 and 80%. Now on the 80% it has to be non-condensing. So I'm giving you some mechanical engineering terms here, but don't pay too much attention to that. What I'm saying is that the temperature range and humidity are combined. Okay, you can't just say humidity by itself. without talking about temperature, without talking about, heat load and all the rest of that stuff. So it's a complicated thing if you're not a mechanical engineer, but the point is that there's a range where I don't want static and I don't want water condensing on things. Okay. Environmental monitoring. Yeah, I'm going to have recorders that's recording the temperature and the humidity and all the rest of these things and making adjustments. This is not one of those scenarios where you typically just, like this cooler exam you're showing right here. I mean, this is probably not one of those things where you just have a thermostat on the wall that says, yeah, I need more. That's not the way that works. A typical home environment, the air conditioning runs and shuts off and then turns on again and picks up and then shuts off again, right? That's how they're designed for homes. That's not how these are designed. These are designed to run non-stop. They don't ever shut off. So they need a different type of control that talks about how much cooling they're actually getting. So something simple like thermostat, no, they need a whole different class of environmental monitoring. They talk about reliability tiers. Now, we kind of sort of talked about this one time before when we were talking about, do I want 5 nines availability? So this is one of those things where they talk about a tier 1. A tier 1 basically says, hey, look, this is not all that important. I don't have any generators. Maybe I have 1 ups. I have a single power feed coming to the company. I just have 1 HVAC air conditioning system, and my availability is probably going to be 99.671. Skip down to tier 4, where I have 2 generators, because one of them could break, 2 UPSs, because one of them could break, 2 power feeds, because one of them could break, 2 air conditioning systems, because one of them can break, and now I get 99.995. So how much is that going to cost me? Holy moly, can you see how the cost difference between tier 1 and tier 4 is about double? Okay, good. So 5 nines, 99.999, that's only 4 nines, but okay, who cares? 5 nines means one heck of a lot of redundancy. So you don't typically go in, you don't just pick a number. You pick something that is representative of what your requirements are. The availability is what determines how much money you're going to spend. Okay, the next one is on security, 1102. So security at data center is probably kind of an interesting thing. First of all, where are you going to put this guy? You need to be thinking about natural things like fires and floods and tornadoes and hurricanes and earthquakes. So, I mean, if you're going to put it in a wooded area, you're probably going to need to, clear cut all the way around your facility so a forest fire is not going to go in. Is the forest fire going to take out your utility lines? Or they're going to have to be underground. Is it in a coastal area where I'm going to have flooding? I mean, there's an awful lot of stuff you have to think about. And then, of course, the perimeter. I need, honest to God, fencing. Maybe a berm. Maybe a moat with alligators. Okay. Probably not alligators. But yeah, I'm going to need something to keep people from walking up to my thing. Clearing the vegetation. Here's an interesting thing about the signage. If you go to one of these Microsoft sites, when you go up to the guard gate, the main entrance, nowhere on the sign, nowhere on the gate, does it say this is a Microsoft data center. It doesn't say that. In fact, it doesn't say anything at all. Let me give you a slightly different example. When SpaceX had a facility not too far from here, I decided to just drive up and say hello, kind of a thing. So I drove up to their facility, and there was a guard at the gate, and I said, so, I'm just driving around seeing what's going on. And they went, oh, yeah, sure, you need to leave. But there was nothing there that said what the company was or what's going on. So it's kind of weird that you might think that you don't identify this as a data center. Kind of weird. Okay. Obviously, you're going to have access. You're going to have access badges. You're going to have one of those vehicle traps. You may have seen in the video where this little wall came up. And so when the vehicle went through while it was being checked, you won't be able to go forward. You won't be able to back up. It's a trap, vehicle trap while you're getting your security squared away. So the trap and inspect is done at the at the vehicle level, and then you see the guy walk through that little cylinder, that's a trap and inspect at the human level. If you step into that thing and the door closes behind you and you don't have the right biometrics or you don't know stuff, the alarm goes off and you just are trapped there. Okay, so a man trap. Okay, cool. And then, of course, the 19-inch racks themselves. Now, here's something that's kind of weird. If I'm a data center, big data center, is it likely that I might have a competitor using CPU components on the exact same rack as some other company? In other words, two companies that are competitors could be, side by side. Is that how that works? I mean, or do you want to have some physical security between the two? And that's kind of an interesting concept. The way virtual machines work now, we don't normally have that problem because, I mean, in theory, if it was a physical machine, then, somebody could go in there with a cable, and, put a cable between the two machine kind of a thing if they knew which one was which. In a virtual world, you never know which one is which. And hell, in a virtual world, they're probably moving nonstop. This one's over here, and then this one's over here, and then, they just kind of move them around the physical machine. So that's kind of a less of a thing now. The tools. Okay, on a page 1103, talk about the System Administrator Toolkit. This is actually pretty doggone cool. We're going to spend a lot of time talking about this. Okay, so here's the things that you ought to have. Okay, I'm not going to go through it all, but I'm just going to point out a few things. Yes, you need a flashlight. Yes, definitely. A tape measure. Yes. All these kinds of things. Talking about an inspection camera. Well, like a dental camera, thing. And then you need a screw kit, you need a thermometer, and all the rest of these things. So let me just give you an example about a digital thermometer. So I have an infrared camera. Okay, this is a FLIR. And so basically, I do this when I'm designing a system or a data center kind of a scenario where you walk up and you just turn this thing on and point it at the rack. And then on the screen, you get to see exactly what it looks like. You can find a hot spot. You can find a corner of the rack that's not getting cooling for some reason. And then you go there and you find there's a piece of paper or cardboard or something that's in the way. Okay? So you walk around just looking at everything with a digital thermometer. That's an excellent, excellent idea. The other is these cable testers. So I have a cable tester that'll tell me if all the wires are connected and all the rest of the stuff. And then it has an extra really cool feature. If I plug this into a cable and then go to this end and plug it in the cable, it's actually, in addition to telling me that how the cable is, it's going to tell me how long the cable is. This is a time domain reflectometer, TDR, where not only does it analyze the health of the cable, it tells me that it's 100.4 inches long or feet long. Okay, that's pretty cool stuff. All right. So you need all this good stuff. You need spare power cords and grounding strips and cable ties and all the rest of this stuff. All sorts of extra spare cables. Now, Q-tips, cell phone, electrical tapes. Okay, now to the very, very bottom of this list, it says a 6-pack of good micro beer. Yes, suggested minimum. Okay, so they were having a little bit of fun there. But yeah, so I think we're actually missing something off this list that they don't show. Now, I'm not talking about the embellishment that I just basically showed you guys, a better digital thermometer and a better cable tester. I'm talking about something that's not on the list that really needs to be on the list. A label maker. Yeah, you need to label stuff. Let me tell you a story. Okay, so we bought a brand new UPS. So we have this UPS. And, what we were doing, we were shutting down one machine, unplugging its cable off the old UPS and plugging it into the new UPS and then bringing back up, right? And then we go to the next machine and we shut it down and pull the cable and plug it into the new UPS, right? So I'm back there in the back pulling cables and they say, okay, it's time for you to, we're ready to pull the cord from the SQL server. And I say, okay. And so I pull the cord from the SQL server and they go, oh my God, what did you do? And I go, well, I pulled the cord. Well, that was the email server. And it had not been shut down. Why? Because the damn things weren't labeled. If they were labeled, I would have been pulling the right cord. Okay, just saying. All right, we are definitely coming up on the 15-minute mark.